Welcome back to the Nodal Analysis series. So now we will look at the circuit with the dependent sources. So the first example is that we have a circuit with a dependent current source. So we can see that we have a current source here which has a value of beta times I naught. And I naught is the current that is basically flowing through this resistive R3 branch. So again, our question is that use a nodal analysis and find all voltages and currents. So as we need to write the nodal analysis equation, so we will determine the number of nodes. So basically we have two nodes here which are labeled as V1, and the second node is basically labeled as V2, and third is ground, which is will be labeled as basically reference node and or 0 volt. So let's try to write the equation for this circuit. So we will write the equations in the same fashion like we typically do for the simple circuit. So for the V1, we will assume that all currents are leaving. So this current is leaving, the current through R1 is leaving, current through R2 is leaving. So what will be the equation for the V1? So that will be like this current, which is basically beta times I naught. So we will put it just like this, beta times I naught. Then we have the current through R1, that will be V1 minus second node, which is 0 divided by R1. Then V1 minus V2, okay, for the current through R2. So V1 minus V2 divided by R2 is equal to 0. Okay, so we have this equation here, and then secondly, let's write the equation for V2. So what will be the equation for V2? So equation for V2 will be, again, all currents are leaving. Okay, so let's assume that now the current that are basically leaving the node R2 are this one. Okay, like this current is leaving, this current is leaving, and this current is leaving. So what will be the equation for the current through R2? So this node V2 minus V1 divided by R2. Then current through R3, that will be V2 minus 0 second node, okay, divided by R3. Then this current IA, which is basically it coming to the node, but we assume that all currents are leaving, so that will be minus IA is equal to 0. Okay, so this is by our equation. Now the next thing is, okay, basically if you look at these two equations, we have three variables, okay, V2, V1, okay, IA is a constant which is basically given for this example, and the value of IA is 2 milliampere. So this is given. R3 is given, so value of R3 is basically 3 kilo. R1 is given with the value of 12 kilo. R2 is given with the value of 6 kilo. Okay, and the value of beta is given, beta is basically 2 here. So we have three variables, like if you look V1, V2, and then I naught, okay, which was basically our control variable. Now what we can do here, whenever we have such scenario where we have basically control variable, we will look at the circuits and try to find out where exactly is this control variable, okay, in the circuit. Okay, so if we look at this circuit, we can find that I naught is basically the current that is going through this resistive R3 branch. So what we can do, we will write the equation for the control variable, that in this case will be current through R3, that I can write that I naught is basically difference of nodal voltages current. Okay, so current through R3 is basically what, V2 minus 0 divided by R3, okay, or simply V2 divided by R3. So what we will do, after getting this control variable equation, we will put that in our original equation so that we can eliminate that variable. So let's put that, and let's put up the value of the given parameters also. So beta is 2, so 2 times of I naught. I naught is V2 divided by R3 plus V1 minus 0. Okay, so let's put up the values also. So what is the value of R3? R3 is here 3 kilo. So V1 divided by R1 is 12k plus V1 minus V2 divided by R2. So R2 has a value of 6k here is equal to 0. Okay. So I have just put up the variable values in my main equation. Let's look at the V2 here, V2 equation. So again V2 minus V1 divided by R2. So R2 is 6k plus V2 divided by R3, which is 3k, minus IA is basically 2 milliampere, is equal to 0. So now we have two equations with the two unknowns. So we will apply the same simple approach that we have been doing in the earlier examples. Multiply this with the lowest common multiplier of all the denominators. So we have 6k, 3k and 12k. So we can multiply this with 12k. This equation we can multiply with the 3 and 6. We can multiply with the 6k. So typically we choose the biggest number, okay, in the denominator for the simplification. So if you multiply this equation with this, so what will we have here? So 12 divided by 3, okay, so that will be 4. 4 times 2, 8. So we'll have 8 times of V2 here. This 12 cancel with 12, so we have V1. Then 12 divided by 6, we have 2. So 2 times of V1 minus 2 times of V2 is equal to 0. Okay, so basically we get 2 multiply with 2 here, and we have just simplified this as 2 times of V1 minus 2 times of V2. So let's further simplify this. So V1 and 2V1, so that will give me 3V1. Then I have minus 2V2. Sorry, we have like not 2V2 here. We have two values, 8V2 and minus 2V2. So that will give me 8 minus 2, 6. 6 times of V2 is equal to 0. So this is the simplified first nodal equation. Let's get the similar one for this case. So again multiply with 6. So this 6 and 6 will be cancelled. So I have V2 minus V1. 6k divided by 3 we will get 2. So 2 will be multiplied. 2 times of V2 minus 2 times of 6, 12. Million k will be cancelled. So 12 is equal to 0. Let's rearrange it, putting in the order minus V1 plus 3V2 is equal to 12. So this is my second nodal equation in the simplified form. So the next we need to rearrange them, okay, either again using Gaussian elimination, your scientific calculator, or simply substitution. So for example, I can substitute that V1 is basically is equal to 12 plus 3 times of V2. Okay, so from this equation 2 we can get V1 is basically, we can use either equation, okay, to get V1 or V2. So idea is get the first one and then put it in the second one. So let's put it here. So we'll have 3 times of V1. V1 is basically what? 12 plus 3 times of V2 plus 6V2 is equal to 0. So what will we get here? 12 times 3, 36 plus 3 times 3, 9 times of V2 plus 6 times of V2 is equal to 0. So 9 plus 6, 15 V2. So V2 is basically what? 36 divided by 15. Okay. So V2 will comes out to be 36 divided by 15 here. So if you further simplify this one, that will give me a value of what? 2.4 volt. Okay. So we have the value of V2 that comes out to be 2.4 volt. So we can put up this value, okay, that we have obtained here in the second equation. So that will give me value of V1. So V2 is basically what? 2.4 volt. So 3 times of 2.4, okay, plus 12, that will give me V1 value that comes out to be 19.2 volt. Okay. So this way we can get the values of V1 and V2. So there was, we need to put up minus 12 here. Why minus 12? Basically V1 will go to the other side, and this 12 will come to this side. So minus 12 plus 3v2. Okay, so if we recalculate this value, because v2 is basically what we just found, that the value of v2 is 2.4. So minus 12 plus 3 times of 2.4, that will give me minus 24 over 5 or minus 4.8. Okay, so minus 24 over 5, or we can rewrite this as minus 4.8 volt. So this is the way to solve all such examples, even if we have a dependent current source here. Thank you so much.